So hi everyone, today we are going to solve Leetcode 42 trapping rainwater, which is a hard problem. Okay, so let's read the problem description. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Okay, so basically what this is an array of heights. Okay, so we are given an array of heights. What we have to calculate is between those blocks. Okay, each block is of height 1. Between those blocks, how much water can be trapped. Okay, as you can see on the left bound, there is no boundary, and as well as on the right bound we have to consider that there is no boundary. So if there is an empty space on the left bound or the right bound, we won't assume that water can be trapped there. Okay, so apart from that, we can see water can be trapped here because this is an empty space between two big walls, and this is also an empty space between two heighted walls, and this is also an empty space. So here all of these, like 1 2 3 4 5 6 blocks of water can be trapped here. Okay, so now let's just go to the whiteboard and I'll explain you how this will work. Is, see, I've just tried to mimic the array here. Okay, blue blocks represent the water that can be trapped. So now what we are going to do is we are going to use two pointer converging technique, which means what we are going to do is place the left pointer on the left, place the right pointer on the most right, and then we start converging it towards each other, and that's how we calculate the water blocks at every step. Now we are going to take two extra variables, which is left max and the right max. Okay, that will depict the highest left boundary or the highest right boundary. Okay, so now what we do is we start calculating if the left boundary is less than the right boundary. Yeah, that's the case in this. So what we're going to do, if the left boundary is less than the right boundary, the water that can be stored here, that depends on the left max. Okay, so if the left max is greater than our current left, so it means that there is a space. But as we can see, left max is not greater than the left, it's equals to the left, so we don't have any water that we can store here. Okay, so as we can see, we don't have any water that we can store here. Left max minus left equals to 0. So we don't have any water, so what we do is we move the left pointer. Now we do the same thing, we check if the left is less than right. No, it's equals to right. So in that case, what we're going to do, if the right is less than or equals to left, then we check the right the water in the right boundary. So we see if the right max is greater than right. No, it's equals to the right, so we don't have any water that we can store. We can just move the right pointer. We check if left is less than right. Yes, that's correct. Okay, so what we do is we see the left max. If left max is less than if the left max is greater than the left, no, that's not the case, it's less than the left. So we move the left max. Okay, because this is the current maximum boundary on the left, and we don't have any water that can be stored. We move the left pointer again, we check that again. If the left is less than right, yes, that's true. We check the left max. If left is less than left max, yes, that's also true. So it means that we have some space here. So what we do is left max minus left. So as we can see, 1 minus 0, we have one block of water that can be stored here. Okay, so what we do is we move the left pointer, we follow the same process again, check if left is less than right. No, it's equals to right. We go on the else part, we check if right max is less than right. No, we check if right max is greater than right. No, it's less than. So what we do is update the right max pointer. Then we move the right pointer again, we check it again. Left is 2, right is 1, so right is smaller. We check the right max is also greater than this, so we see that we have one block of water that can be stored here. So what we do is right max minus right. 2 minus 1 equals to 1, so we have 2 blocks of water now. And what we do is we move the right pointer again, then we check the left pointer and the right pointer. So left is 2, right is 2, both are equal. So we check if the right max is greater than the right. No, it's equals to right, so we move the right max again. We said this is the new max. We move the right pointer, we check if left is less than right. Yes, that's true. We check if the okay, so we check if the left max is greater than left. So we see left max is less, so we cannot we don't have any water that can be stored, and we move the left max pointer, set this as a new max. We move the left pointer again, then we check on the left if left is less than right. Yes, right is greater, so we check the left max is greater than left. Yes, that's also true. So what we do is left max minus left. 2 minus 1 equals to one more block of water. Okay, so now total water is 3. We move the left pointer again. We check if left is less than right. Yes, that's true. Then we check if the left max is greater than right. Yes, that's also true. So what we do is subtract 2 minus 0. Now we have 2 blocks of water here. So our total water becomes 5. We move the left pointer again. Then we check if the left is less than right. Yes, that's true. Then we check if the left max is greater than left. Yes, that's also true. So 2 minus 1, again 1. So we have our total 6 blocks of water. Now what we do is move the left pointer again as soon as our right and left pointer meet on each other. So we cancel out the loop, we break the loop, and now as you can see we have our total 6 blocks of water here. So this is how, by using 2 pointers converging technique, we can solve this problem. Now let's just go into the code. I am gonna quickly write up a solution. Okay, so this is a solution which runs in big O of n time. Okay, so we just have to iterate through it once, and as you can see what I'm doing here is I've taken 2 pointers left and right, then we have taken left max and right max. Okay, we have taken a variable to store the water. Then we check if we run the loop until the left is less than right. Then we check if the height of left is less than height of right. We check if the left max is greater than height of left. If yes, then we are going to just increment the water. Okay, otherwise we are just resetting the left max. Same goes for the right one, and this is how we keep on incrementing the water on every block. Like on every step we calculate the water on that block, and that's how we get the total final water. Now let's just run this, and as you can see both the test cases are passing successfully. We just submit the solution. Okay, so as you can see it has a 0 millisecond of runtime, which beats 100%, and memory is also looking good. So I think this is a optimal solution for this problem. Okay, so please let me know in the comment section if you guys have any issues or queries, and until then, thanks for watching.